All right, lesson 3.4, equations of lines. So, to be very honest, basically when I do this, I almost always use slope-intercept form in doing any problem. However, on the state test, I don't know what form they may ask. So you do need to know both forms. So we know point slope and slope-intercept. The main difference here, in point slope, you can use any point on the line, x1, y1. With slope-intercept, the y-intercept here is really the point 0, comma, b, whatever b is. It's the point that's on the y-axis, where it crosses the y-axis. So that's the main difference. Slope-intercept form's the easiest one to use, but again, you need to know both forms. So as we go through this lesson, I'm going to do some example problems with you that incorporate both. Another thing to be mindful of, they give you an example here, show you on the graph. Here's your y-intercept, which is -2 because that's where it crosses the y-axis, and then your slope is rise 1, 2, 3 over run 1. So there's your slope, there's your y-intercept, there's slope-intercept form. A couple of key types of equations, and we talked about these in the slope lesson, but when it's a horizontal line, again, the equation is always going to be y equals a number. So y equals a number for a horizontal line. And then, and that number is b, the y-intercept, where it crosses the y-axis. For a vertical line, it's x equals a number. In this case, they use the letter a, but a vertical line, it's where it crosses the x-axis or the x-intercept. So horizontal, y equals, vertical, x equals. All right, so let's look at some examples here of some different problems. It says write an equation in slope-intercept form given the information. So all you're doing here is plugging right into the equation. So this is where you need to know the form. So slope-intercept is y equals mx plus b. So m here is 4, so this would be y equals 4x. B is the y-intercept, which is -3, so you put -3. Simple as that, just plugging in. All right, number 4, write an equation in point slope form. So this is different. So it's y minus y1 equals m times x minus x1. So 5 is our m, this is our x1, this is our y1. So we're plugging into the formula y minus y1, which is a -2. So the minus sign does not replace the negative sign, equals m times parentheses x minus x1. So if we simplify this, what we need to do is change, and that becomes y plus 2 equals 5 times parentheses x minus 3. Let's do another one real quick here. So let's do number 5, y minus y1, there's my y1, -3, equals m, 1/4, times parentheses x minus x1, there's my x1, minus a -2. So again, I have to change. So it'll be y plus 3 equals 1/4, parentheses x plus 2. Okay, here they want us to write an equation of the line through each pair of points in slope-intercept form. So the first thing I have to do is get my slope. So here I'm going to do change in y, so my y's went up 5, over change in x, my x's went up 4. So change in y over change in x, so my slope is 5/4. Since I want slope-intercept form, I want to use this point right here, 0, -1, because that is my y-intercept. Remember, slope-intercept is the y-intercept, which is of the point 0b. So that one starts with 0, so it'd be y equals m, my slope, 5/4 x, plus b, my b here is -1. Now, we look at problem number 8, it's a little different because they don't give us the y-intercept. I'm still going to start the same way, change in y, so that went down 9. Change in x, that went down 3. So that would be -9 over -3, which simplifies to 3, so that's my m. Now I'm going to pick a point. I want to pick this one. I'm going to start with slope-intercept form, y equals mx plus b, and I'm going to plug in what I know. What I know is I know a y, so a y here is 3 for my point I'm using right here. And then I have an x of 4, so y equals m, which is 3, times my x, which is 4, plus b. Now I'm going to solve for b. So 3 equals 12 plus b. Subtract 12 from both sides, and that's going to give me negative 9 equals b. Now I have my b and I have my m. So now I can write the equation y equals mx plus b, or in this case, minus 9. Okay, let's do a little bit more difficult one here. I'm going to write over this just a second. So I'm going to use my pen here to kind of clear these words out and make it a little bit easier to write. So here it says do one where it's perpendicular. Okay. So perpendicular means the slopes are opposite reciprocal. So write an equation in slope-intercept form of a line containing 3, 2 that is perpendicular to the given line. Okay, so the slope for this one, m, is negative 2. So my perpendicular slope would be the opposite, which is positive. Reciprocal means I flip it, which would be 1/2. So that's the slope I'm going to use, and I have to go through this point. Again, I've got to put it in slope-intercept form. So this time what I'm going to do is I'm going to start with point-slope form and change it. So y minus, this is my y1, equals m times parentheses x minus, there's my x1, oops, 3. So now, slope-intercept form, if we remember up here, slope-intercept form is y, I don't know why it keeps jumping here, sorry. Let's make this a little bigger. Slope-intercept form is y equals mx plus b. So that means I got to get y by itself. So what I'm going to do in this problem is I'm going to isolate my y. So I'm going to do distributive property here, which is 1/2 x minus 3 over 2. Then I add 2 to both sides. You can use your calculator here. If I do that, I get y is 1/2 x plus 1/2. So that would be slope-intercept form. So just another way of getting that problem.